everybody. I'm very honored to give a talk, and on behalf of the team, our paper has been published on one of the top-ranked journal, Information Sciences. The title of the talk is called Statute Recommendation, Re-ranking statute by modeling case-statute relations with the interpretable handcrafted features. So we're going to start with the content, with the background and motivation, and to explain the related techniques of the low article prediction and the proposed approach to such as re-ranking. Re-ranking is a revolutionized way that includes a corpus, retrieve candidates, and rankers. I'm going to explain what they are, and how we can achieve all these later on. And then we have the experiment and evaluation to answer our research questions, and we have the conclusion and future work to justify why you should consider citing our paper. As you know, divorce is an issue that happens every year, and it's not just the case of China where my collaborators are based. You can notice that the trend for the marriage is on the way down over a period of 9 years, and then for the number of divorce cases are on the way up throughout the 9 years. And as you know, by 2019, the annual marriage rate in China had fallen below 10 million pairs, while at the same time, the divorce rates had reached 43.53%, ranking the first in the world, which means that people in China get divorced a lot more. And there are a lot of reasons due to the fact that both husband and wife, they cannot get along with each other well, and the stress due to the work, and also very different values for their life, different goals, and maybe husband and wife live in different cities, and then they went apart, and also because of the affairs they had. So we have to solve these issues globally. But then in this case, we can have the increasing needs of the legal guidance in divorce cases. And the motivation is to allow us to have the ability to utilize AI to assist the legal judge prediction, LJP. So the reason is that it will provide more efficient and equitable ways to protect the rights of the legal freedom for marriage. And it's also have the concrete values of the intelligent statute, which means that the low article recommending tool. So what are the benefits? It allows the lawyers and judges to handle divorce cases properly, and to help the lawyers and judges to improve the work efficiently, and to help common people derive advice and recommendation on defending the rights. On the most concerned aspect of AI and legal research. So we can have the legal judgment prediction, and in a way that it deal with the legal case retrieval, the court view generation, and so on, because it involves a lot of documents that also sum up different cases, and then several cases they will lead to a statute. So it will help the lawyers and judges to make a better decision. First of all, the system can allow low article prediction based on what has happened, and then if there's a close match, therefore there's a high probability that you end up having a similar or the same decision, and also to charge the prediction, because you will end up in different cases, especially when involved with a lot of financial device, and also even sometimes leading to potential prosecution that can get to a prison term prediction. So the best way is to allow a system to make predictions on the work that the judges and lawyers are doing. So the related techniques of the low article prediction, there are actually three types. One is called recommender systems, which is a common way to improve recommending effectiveness, is to utilize the novel features of the recommended items and the improve query. And none of the existing LAP approaches utilize case-statute relationship explicitly, because it only try to provide the basic function, whereas in our case that we focus on case-statute, because each statute will involve with several cases, and they may also take a period of time, and it's not easy to handle, and because the system will have to understand the languages, terminology, and what leads to the kind of decision, and also to work with the lawyers for some time to understand how they think, how they behave, and also collaborative filtering is widely used in recommended systems. Why? Because that you can only filter out the things you do not need and then focus on the one that works. So, but however, none of the existing LLP approaches discuss how to retrieve statutes candidates in detail because they are only based on case. And when there are several cases, they will get to statute, and there is no easy thing. And each statute may also be different. And learn to rank is widely used in information retrieval and recommendation. And the reason is that it's very useful for the system to learn some level of intelligence. And then we are very fortunate to say we are the first one to adopt the learn-to-rank techniques in LLP. I'm going to explain in detail. So the approach, the re-ranking framework is the one. First of all, we derive the statute candidates by retrieving similar cases. And we calculate the similarity between legal cases using keywords, and we consider both efficiency and accuracy. So in a way that we understand all the keywords, and we then focus on efficiency because you need to get it quick, and then do not take you a lot of time, and it has to be accurate because if you are not accurate enough, it may lose the purpose. And then we re-rank the statute candidates because we have to define the case, statute, relational features, and we apply the features in different rankers. So just to sum up, this is the diagram to show our figure 1. So this is a new case, and there's a collaborative filtering. The similar case search engine is here. Then with the historical data that gets to retrieve similar cases with keywords. So the keywords will be the one to be checked and to be validated, and rank cases with the keywords weights. So why weights are important? Because it corresponds to the importance and relevance. So then we then get to the top K1 statutes, and then there is also a statute ranker. So what does it do is that it involves with 2 micro steps. So the first step is to have the case-statute relational features. So because what leads to the cases with statute, and we need to establish the kind of the relationship and also understand why several cases, and you do not get into the decision A but B, and so we have to also understand that. And then once you understand that, learn to rank will be able to pick up all the algorithm to mimic the decisions being decided by judges, and also to understand how other lawyers they think and work through the system. So then get to the top 2 statutes. So it's the simplified version of our framework of the proposed statute recommending approach. So our approach in the real-world corpus. So of course, there are existing public data set like CAIL 2018. However, it's not applicable for the proposed approach. So there's also no original legal judgment document supporting retrieving required fields, because first of all, some countries may still use a paper-based system, and when you want to make everything into digital format, and it has challenges because you have to store a large amount of text-based information, and then you have to even process the data to some extent. So then in this case, we are very fortunate to work with a partner that do not have this issue for both funding and also accessibility. So we use the Chinese judgment online, and the detail is on our paper, and it's based on 2015 to 2016 divorce cases, and it's the first round civil instances. Like those people who don't get married and divorce is the first round, the first time, and the first round is the one we focus. We then download 30,000 cases. However, 19,860 cases are the one we concentrate, and then we also show all the key numbers. So how do we actually perform our processing? First of all, we have plaintiff description and defendant description. So there are 2 sides. So then we train and test. And then with the feature measuring, we also understand this. And then they will also put into the statute. So we will have to read them, and then you get to the statute and together with the case analysis, because there's also some case analysis with the details to explain what leads to this decision, and also the feature for measuring relation will also train and learn, so that the candidate statute will become better and better in the process. It's also more developed, so that the ranking will also look at how accurate your results are. So it shows some kind of indication for the quality and reliability. And the similar approaches are as follows. So there are steps. So segmentation, because a lot of data is everywhere, so we use this. So there's one thing called term frequency inverse document frequency. So means that it's actually looking at how frequent the term will come, and then also how often the term may be used or being against. And the keywords, in this way, we have the try methods where there are three things involved. IG, that stands for information gain, how much information has been gained in the process, and the WLLR, that stands for weighted log likelihood ratio, means that the likelihood that some kind of important term may appear, and what's the percentage of their appearances, and the weighted frequency and odds, WFO, means how frequent that those important things come up, and the odds against it too. So the information retrieval, we have an algorithm, so we call that with a word, and then we search for the keyword. So the post, which stands for part of speech, because during the court, sometimes the plaintiff and defendant, they have to describe their rationale while doing so. So it has been recorded in part of speech post. So in this algorithm, we have to look at a keyword with a post, with a TF-IDF, that stands for term frequency inverse document frequency, and or weightage of the key, the keywords, how important, how relevant they are. Inverse index is also important because we have to do this systematically. So the algorithm is that you follow with the case. So the case is the one to follow with the part of speech, and also with the term frequency inverse document frequency, and with the weightage for the keywords. And so you are going into loops, and when you then until you find all of them, until the loops has come to a stop or come to an end. And also the weights of cases, because you need to know the importance and relevance. So this is being represented by the part of speech and the sum of it, and with the constant in front, and with the TF-IDF, term frequency inverse document frequency, and also the weightage for the key, and with another constant in it. So then the weightage of cases is to know how important these cases are, because if it has been well known, then it will have a higher weight, and if it's less well known or represent few cases, then the weights are having a lower number. Then similarly, also the statute will have the weight. So you get the idea that after getting the weights of the cases, then you then collectively you can then obtain the weights of the statute. So the baseline, there are also different methods, including commonly used method or new methods such as TF-IDF, weight TF-IDF, DEA related, though too vague, and then for details they are in the paper because of the time constraint. And what we have done is that we explain what these methods are, and then we compare them. And then this is the result with the recall and with the precision, because they are usually used as the matrices to evaluate the performance. And also we have the average precision, because we need to understand how they perform when you have a different top K prime statute, because it means that there are more and more statutes, and then your result got to be resilient and robust. You cannot be like ups and down like stock market. You go once you get to some point, it will become saturated, almost like come to an equilibrium state. So as you know, we have run different models, and they have very similar patterns. A lot of them at the very beginning it was different result, but when it comes to like between 17 to 19. For the K prime statutes, then a lot of them will get to average statute recall for 0.8 and above. It will come to almost like 0.8586, the kind of range. And then similarly, when we perform an experiment, then we also have similar results. And as you know, that the only difference is that when you top values, the top 50 will get a higher value because you have more things to refer to it, to compare, and then to cross-check. And then whereas you only have 5, you have a lower statute record, which means that if there are a lot of cases, will end up more or same results, though there's an indication for reliability. You are more likely to get similar outcomes, and you're more likely to get similar things. Yeah, so that's the end of the first experiment. Second experiment is that we have the basic features, because when we're doing the information retrieval, there are a few things to look after. So first, the initial unigram pairs, which is initial code up. So one up consists of word and a case, and a word from the statute. So you have combine the case, combine the statute, and the size of up is too large to train the ranker, because when it's too large, then it's probably not ideal. So we then have the selected unigram pairs. So that we then identify the key variables for this. So then we then get under 4,000 ups. So the key variable is F1 equal to 5, F2 equal to 400, threshold equal to 1, threshold equal to 100. So this is the diagram. So it then allows us to know what the thresholds are. So then we can then pay attention to it. Then, of course, we should have the novel features, because novel features will be the one to determine its uniqueness. And of course, we need to demonstrate the novelty. So usually what we need to emphasize is that there are some factors we really have to carefully deal with them properly. So that includes words overlap, because when they overlap means that whether there's emphasis or whether there's something that has been said all the time by defendants or plaintiffs or even lawyers themselves, and roles and special group consistency, because the roles of lawyers and also plaintiff and also special group consistency, sometimes that you may be allowed to bring in witnesses, and in some cases or rare cases that even other independent evaluator may be part of the process just to help the judges to make a better decision. However, it may not happen very frequently. And a judgment consistency, because it cannot be in the case that, like, oh, you have a divorce code, and then there's another one, and you end up to two totally different outcomes. So you do not go for something that is so unreliable. So the judgment got to be consistent. You have similar cases, similar statutes, and almost all the factors are very similar, and you will expect that the outcomes are pretty much the same or similar with a high extent of accuracy. So the relationship consistency, because the relationship between different people and also different institution and so on, they're going to be consistent. It cannot be like between a certain individual and institution, and you got some special privileges and you maybe get away from it. And so, and the features based on LDAs and other special techniques that we have. So all these factors considered by judges and lawyers when they handle divorce cases, because they have to check a lot of information. What makes it challenging is that the lawyers and judges have to read a lot of documents, and they have to listen to what both sides they have said and defended themselves, and then make a fair cases. Usually it may also involve several rounds. And then approach to train rankers. So in this case, that we can have the point-wise ranking only considering the query item, which stands for classification or regression, and trick a statute suitableness as 0-1 classification problem, because if we just need to know whether you get 0-1, so we can use a various kind of algorithm to identify. And if we use the pair wise ranking considering the item 1 and 2 pairs of a query, we can use SVM rank. And if we use the list wise ranking considering the query and items list, we use DLCM, the list wise context model, and we can then use a different learn to rank algorithm. We try different features that includes the vector to bird and also vector to AOO bird and basic features, normal features, and so then we then have our research question. So when we were doing the experiment evaluation, sometimes we double check with our research question. So the first research question is how much can the proposed relational features improve LAP performance comparing with the others. So in this case, that we then use recalls and precisions as the main matrices as explained earlier, and then when we run different algorithms, and then we then ensure that every parameters and all the setup are identical, so that we can ensure the fairness of the result, and we then get a result as follow. And we notice that after running all this, the RSVM basic plus normal will give us the best outputs, because when the search engine purely rely on CF, however, the C multi-label treats statute as labels. They may not be necessarily right. In some cases, completely wrong. So RSVM basic plus normal achieve the highest and the best outcomes. However, there's still a big gap between what we get now as the best outcome and gold standard, because the gold standard will mean that this will be or like a best practice approach, which means that you always will get a best output. So under the best output, you can see there are some gaps. So there can be different reasons for this. I can explain a little bit later if that's relevant. And then for the research question one, how much can the process relational features improve LAP performance comparing to others? So we can also perform the LAP, because LAP is one of the important things that we perform this map values of different ranking approaches. So in this map values, what does it mean? Figure 6 has the highest map value when equal to 3. When you get the 3 here for the top K, you get the highest. And once that you get to highest, you begin to decline gradually. So the average number of a cited statute by a case is 4. When we get 4, we get the highest cited statute. Theoretically, the highest map should be achieved as 4. So when your map values becomes 4, actually, or it will give the best outcome, even somewhere here. Yeah. So the balance, the 0 and 1 labels, that's also helpful. That may be because it's been done by different stages, and then we at the same time we run different algorithms to compare the results. So then now let's move to the second research question. The research question stands for, to what extent do the novel relational features contribute to the re-ranking approach? So in order to verify this, then we have the basic and novel approaches. So in basic, we have just under 4,000 dimensional vector, and novel we have 441 dimensional vector, because sometimes it's very hard to get, and then we use the recall and precision, and also with a map with a K. Yeah, so then we run the result. So in this case, we only focus on better or best performing results. So then we run them against each other. So again, R, SVM, basic and novel will get the best result of all this. And the frequently cited statutes in top K recommendation 1. At the beginning, you have very high value after it drops. Why? Because at the beginning, you don't have those interference, because you know at the beginning you got all the searches, search engine, you get all the keyword, but then after that, when you have the rank statute, it doesn't actually may not get what you need, and you have a sharp decline. However, when you have the RSVM basic novel, it's more consistent, and in the way that we are using it for long term, it's more reliable. Yeah, because you will get more results that may be on your favor, or maybe matching exactly what you need. So the novel features reduce the impacts of the frequency of a statute. As you can see, they are more gradually decreased. They are sort of like this sharp decline, showing as a positive instance in the training set. So for research question 3, what kinds of human interpretable information in cases and statutes play a more crucial role in ranking statutes than others? So the word overlap and LDA play a more important role in training a better ranker, because as I say, you can also remember by keywords, and when he has understand or listen a keyword very frequently, and he knows. Then, of course, the words overlap. You can see that the good news is that there is a high consistency. The results are between 0.67 plus and 0.68 plus. It's a very small difference. Similarly, LDA, they also have a very small difference between 0.68 65 to 0.686. The rates and special group consistency is also have a good value, and of course there are also good judgment consistency and relationship consistency. Then, as you notice that information gain is the one to check. And when you're running different algorithms, you will notice that there's a decline. And then, but however, at the very beginning is very high, and then all of them get to a decline, and then to some algorithm, they are more dominant. As you can see, they are more purple, which stands for LDA. But similarly, in this case, at the beginning is green. Green, that means the words completely after that become weaker and weaker, and eventually that is the issue for the similar one. So several dimensions of role and judgment consistency features are there. So we can see a general decline in this. And then with the third research question, we can sort out the guidelines for writing case description and judgment documents that help recommend suitable statutes. Because when we have those feature type from overlap, LDA, judgment consistency, role and special groups, and it's not an easy task. So we then present a ring of dimension, definition of a dimension, and also we have the indicated instruction. What should we do next, and to guide the lawyers and judges. So in our system can also based on what you were providing, what we had in the past, then we can then find the most match recommendation for them. And for instance, in this case, judgment consistency may be the one, and then it's being in defendant's attitude is the definition of meaning of dimension. So the defendant should express his or her attitude clearly, since it may affect the judge's judgment and thus the suitability of the statute. So with a hefty case that will influence them. So experiment and evaluation scalability is an important issue. Why? Because how can we handle increasing scale? Because we need a system to be able to train and work well, and we also increase the volume, the complexity. So historical cases will be the one to refer. So the TF-IDF vectors of all the cases should be reconstructed, and then the keywords derived through calculating the IG of each word should be regenerated, and then such base could not be uploaded until the number of the newly collected cases reach a certain threshold. Yeah, because it has to reach a certain threshold, otherwise it may not be resilient enough. And then more cases should be used to train the ranker, since the case statute relational features could be easily recalculated. So this allows us to work with the historical cases to understand the implication, and also to suggest the right actions. So applicable statutes, the thing to be uploaded is to collect the specific content of these statutes to recalculate the features for training rankers. Because when you use them, and then once that we have them, we have to recalculate the feature for training rankers, because it will be changed. The status will be changed due to more training, and then after that the system is more robust, and then after that we need to recalculate and update. So similar cases and statute candidates. So what will happen? The process of building the approach will not be affected, because if our system is resilient and with a good accuracy, of course, that it really doesn't matter that much. Even if there are similar cases in statute candidate, we can still find the one we need, and we will not get confused. And that's the benefit of doing so. So just to sum up, we have 3 research conclusions. We design and construct a complete an applicable divorce-related statute recommended system as shown in Figure 1. It is a new framework of the proposed statute recommending approach that we have two-way approaches, and then we provide a very systematic way for very accurate and efficient information retrieval and matching. We propose a weighted keywords-based method for searching for similar cases. The weights of keywords are calculated by integrating their TF-IDF values, types of post tags, and the importance in determining suitable statutes for cases. So then we identify the weighted keywords based on the proposed needs. Requirements. Also, the weights of keywords, we then can perform calculation. Then we perform based on integrating the TF-IDF value, type of post tags, and importance. And then we propose a group of novel interpretable handcrafted features to build a relationship between the case and the statute. So we need to understand the relationship when we then once understand this, and then we then put them in the relational features so that it will help the judges and lawyers to make decisions or recommendations more easily. Because when we tidy them up and we sum them up into the respective statute, we then build a relationship between a case and a statute. We understand why those cases will lead to a certain statute, and then we then get them into a one-to-one relationship. And so in a way that we then can build up a better correlation to calculate the relation vectors for ranking statute candidates. So conclusion and future work, the similar cases searching, so TF-IDF and IG information gain achieve the best results based on our approach and also experiments. The ranking statutes, SVM rank using basic and novel features achieve the best results. We have demonstrated in our experiments, and however, there is still a big gap between the proposed approach and the gold standards. You can see that there is a difference there, and we need to do more to improve the overall quality and efficiency and accuracy. And the future work, of course, will include defining an abstract reasoning model manually and mine a knowledge base for reasoning from case to statute, because at the beginning we have to do it manually. After that, we build understanding, and then the system will be able to train itself and understand better, and then we can provide more test data so they will improve on itself. So then we also need to build our knowledge. When you make a decision, it's not like to follow what you do or predict based on the previous, because you will have to gain a certain level of intelligence. Therefore, the reasoning will be the next focus part. And then why should you cite our paper? Because first of all, we have a very high quality and it's free forever. And please visit and download. And we made a significant effort to make it free for everybody in terms of telling everybody the know-hows. And we design and construct the first complete and applicable divorce-related statutes recommended system. And the steps are pretty easy to follow, and it's much easier compared to other complex systems. We will propose a weighted keywords-based method for searching for similar cases, which can be used for other document retrieval application scenarios, so that they can use similar approaches, especially those weighted keyword-based method that will be extremely useful. And we propose a group of novel and interpretable handcrafted features and to build the relationship between a case and a statute, named the relational statute, calculating the relation vectors for ranking statute candidates, so that we build a relationship between the case and statute to make a better understanding and to help the judges and lawyers and to calculate those vectors so that we can make a better ranking. So in the end, we then made the system to be able to learn how to rank and also to rank with a better quality, since we need to be able to rely on the system to perform the task more and more. So you can please download our paper and sign our paper. Your support is kindly appreciated. We sincerely hope that your encouragement and feedback will also give us the motivation. And thank you so much for everything, and wish you all the best. Have a good day. Bye.